Okay, and welcome everyone to the second talk in this OSGi track this morning. We have Mark Hoffman here, who has been very active in the OSGi world for a number of years, talking about microservices and OSGi, a perfect match. Mark.
Thank you. Good morning, everyone. Yeah, my name is Mark Hoffman, and I'm from Data in Motion, and today I wanted to tell you something about how we in our company realized a project using microservices combined with OSGi. And I want to show the whole track from the architecture, how to build and release the system, and how to get that into an infrastructure. But first, about me and my company. I'm the CTO of Data in Motion, and we are located in Thuringia, in Jena, German company, and we provide consulting work, independent R&D, trainings. And we have something called assisted development. We provide consulting from the first day to the development and training. So we do not just come into your company and tell you something and then go away. We can stay all the process long. So we work for a wide range of industries. Usually it doesn't matter for us. Usually we want to try to bring OSGi in those companies. So let's start. When we talk about microservices, I think everybody of us knows the main topics around it. And this is not a definition, it's just a brief overview of what it's meant to be. It's a technique for service-based applications. We know that. And the goal is to have independent processes and loosely coupled services. Yeah, they want to have a modular structure for software systems. And yes, for sure, we have many Docker containers, many standalone services. We have distributed communication. We have interfaces, and all these interfaces hide certain implementations. So, and the whole system should allow dynamic applications. So we want to combine certain services together or replace services and something like that. So now let's come to OSGi. If we take a look at Wikipedia, for instance, then we see that OSGi is a service platform. It also has independent services, decoupled services. Our interfaces also hide implementations. We also can have multiple implementations for the same interface. We have bundles, modules that are tightly coupled. And OSGi is in general a framework for modular application or libraries. And yeah, we also have distributed communication if you take a look at the RSA specification, for instance. So, sounds very similar. Now to our example. We wanted to provide an application for our local government, which was prototype-like, that is capable to collect data from certain third-party systems. And this is also capable to be connected to, in that case, traffic light controllers directly. That is connected directly to sensors in a city and also connected to certain public transport systems. This was the goal of the whole system. So we wanted to create that based on OSGi. So what should we do? Well, what do we have? We have the smart city application. This is mainly consists of several services running in some infrastructure. We have a web front end for configuration of certain systems. In that case, we will stay with a traffic light controller example. We also have other companion applications. In that case, we have, for instance, an Android application that is capable to collect my commuting data every day. not only the location, also the speed and direction. So, and in general, we have one OSGi backend, many instances, and we also have an OSGi on edge devices, in that case on traffic light controllers. And in addition to that, we have also a traffic light controller that is simulatable in the backend. And yeah, we want to collect data from all our edge devices and as well from the simulated devices. And we want to control those devices. We want to turn them on, turn them off, or change configurations or whatever. The technologies that we started to use is, in general, OSGi. We stay with the complete Apache Felix stack. And in addition to that, we use EMF. Maybe who knows EMF? Okay. For the whole data modeling, we created certain open source projects that make it capable to have OSGi from the REST interface into a MongoDB. We use QVT for model transformation and so on. So we have an end-to-end EMF in our system, which is one of the major parts beside OSGi. We have an ordinary front end based on Bootstrap and D3.js for generating diagrams. And beside that, we also have some third-party companions like InfluxDB that collects the commuting data for our timeline data. We have a MongoDB or MongoDB cluster, and we have a RabbitMQ message broker that is then capable to handle messaging using AMQP and MQTT as well. For our build and release process, we completely use BND based on Gradle. And in addition to that, the release process relied on our Jenkins that is then capable to deploy on our Nexus. As infrastructure thing, we mainly use an HA proxy as entry point for the whole application, for the web stuff, and on back in the infrastructure, Docker Compose and Docker. So this is a very simple example. The main point of the application is just using some certain OSGi specifications and combining them to have a powerful application. And this is just, this is nearly everything that we use. It's declarative services. We use the config admin and the configurator for configuring our system. We use the JaxRS Whiteboard to connect maybe the Android application and front end. And we use remote services and RSA to connect our edge devices. Yeah, and for working with our data stream, we use for sure pushstream and promises. And internally, our messaging or eventing is based on the event admin. So, and yes, there's a new specification coming in R8. This is a messaging. It's currently in RFP and will become an RFC next time, if I have time. And this is I think a framework or a specification that can handle certain messaging protocols using one API. This is exactly what we want to have. We just want to say, okay, I want to message using AMQP, and then I inject my AMQP messaging component. Or the same applies to WebSockets, MQTT. We already have an implementation and already use it. Yeah, and as pattern, we make heavily use of the whiteboard pattern. So, to go more in detail, where OSGi helps us to bring a powerful application to the road is we use prototype scoped services for REST, because it's quite easy because of the garbage collection thing, and you can avoid concurrency and stuff like that. We have our devices, our traffic light controllers. The traffic light controllers are based on a configuration, a setup, which is usually an EMF model for an intersection. And based on that intersection, we have a state machine that can handle the color states of our traffic lights. And we have the same implementation for the traffic light controllers on the road and for the simulated devices. So they run with a configuration, with an intersection, and they do always the same. They generate events that go through the event admin. The difference is that the simulated devices use a Mongo persistence. They get their intersection data from the EMF model from a Mongo database, where the devices in the field don't have a connection to any database. They use a XML presentation of the EMF intersection model that is then also located on the device usually. And all the device data that are generated by the state machine go through the event admin, and then we have certain event handlers that distribute the data to wherever or to whatever we want to do with that. In that case, the device data are submitted over MQTT from the edge device to our backend system, or wherever we have a handler service that collects the data. And in our case, we write it into a MongoDB. And in addition to that, the device service that runs on an edge device will become automatically a remote service if it's on a device, depending on the configuration. And our complete remote service implementation is based on messaging. I say in that case, we use MQTT as protocol because we have to handle edge devices. But to be more concrete, it's based on the messaging RFP API that we currently use. Yeah, and the front-end service uses the whiteboard pattern to get device services. So this is the whole combination of what we used. It's just a combination and configuration of components, nothing else. This is an example to show how it works to initialize or to start an edge device. It has its XML configuration of its intersection on its device. And if we start the system, then this XML file is loaded, and the device itself, the intersection, is then configured. And the device service will be created using the config admin. And because we are on an edge device, we say, okay, give an additional property to be a remote service. This is it. And the rest of our remote service implementation takes care that this remote service is announced to our backend. And this is exactly what happens on the backend side. We got a proxy for our edge device, and then this device service is registered using the whiteboard pattern. It is really quite easy. And then from the front-end side, we are capable to say, okay, we can update the configuration, we can start or stop the device and whatever. And the whole communication from the edge device is then going over the messaging adapter to MQTT. And on the backend side, you then have a simple MQTT handler, push stream, that is then capable to write all the data into a MongoDB. The good thing here is, I will not mention that too much, that we use EMF. EMF is capable to define a data model And you have many possibilities to serialize or deserialize this presentation or representation into several formats. In our case, we have adapted to write all the models into the MongoDB and read it from the MongoDB. On the other hand, the default possibilities are saving XML files, XMI or JSON or whatever, or YAML, or a binary stream. And in our case, we use, in that case, the binary serialization from EMF to transport all the data over MQTT. This makes it a little bit smaller, the packets. So, and on the other side, if we have our data from the push streams, then we just have to deserialize the byte array into an EMF object again. And this is a quite nice combination of these toolings, EMF and OSGi. So, and now let's take a look to the simulated devices, and if you take a look at it, it looks quite similar. It's nearly the same. What we do, we load all our simulated devices, in that case, from a database. And then we register each device using the config admin as a service. This service is then registered as whiteboard at a devices service for the front end. And then we have a combination of simulated devices and edge devices. And each time you plug in a new edge device somewhere or you test locally, then you can see it in the front end and you can test with it just by using remote services. And the behavior here is the same like I described before. The data that are generated by the simulator are posted using event admin. We have event handler that directly write it into the MongoDB. And in addition to that, we have some other event handlers that write it into our AMQP system as well. And our front end is then connected to the AMQP server using MQTT over WebSockets. So then we get all information or certain information about status changes, for instance, also on the front end side, and are capable to update something or refresh or whatever. So what is the trick in such an architecture? One thing is you can have multiple implementation for the same interface. In our case, it's the persistence for the EMF stuff. We have a so-called EMF repository, and we have different implementations for that. We use, for instance, the Mongo EMF repository for storing all data or reading data from a MongoDB, and we have a file EMF repository for reading files. The second thing is, and this is for me the most interesting and most important part, is the configurator in combination with the config admin make services configurable. Our components are usually all configurable, and we also have sometimes an additional layer in front of all these configurations, especially next example for the Mongo repository. Sometimes you have to define a little bit more than just saying this is my server, this is my database, and you also want to configure something. Yes, my repository is prototype scoped, or can it handle that? Or should we apply a cache or something like that? But these are two different systems. And I don't want to have the configuration, a large JSON with certain entries that no one knows about. And that's why we sometimes create, I would say, meta configurations that are simple to read, and you can usually customize everything, but the default values are very small. And then we have a component that takes this configuration and puts that into certain other configurations and brings the services up. So, and I think this is one of the great things that you can do. And this is exactly what happened with our devices. Our simulated devices are using all the configuration, are all configurable. On the backend side, we are configured as ordinary service, and on the edge side, they are configured, for instance, as a remote service. Remote service is a next thing. Usually when we hear something about microservices, then we talk about REST communication. Everything is REST. I have a new service, I need a REST interface. We don't have that. We just have our service interfaces, and I don't care as a programmer if I get a remote service injected or not. This is a matter of configuration. This is a matter of my system. So, I don't lose the programming style. As a developer, it's more easy to work with my service, and the best thing is, if I don't care, everything can be a remote service. And I can combine everything in my infrastructure like I want. Yeah, and one nice thing is having the event admin internally. You have in your VM one API that you can always use, and if you want to remote that, in our case, we use the messaging stuff to bring everything over the net into another instance. Now I have my application, which is nothing than combining specifications in several ways. The next is build and deployment. We use BND tools, and what I like with BND tools, it's you get an easy start. You get a system very easy up and running. You're capable to create project templates. We created a lot of project templates for our use cases, and then I get a JaxRS Whiteboard service with configuration and example and everything I need from scratch. This is how we start, and this is what BND Tools provides. We have a very good implementation for connecting to several repositories, OSGi repositories or Maven, and we can also make a very nice snapshot release or release process to deploy directly into our Nexus. In addition to that, BND Tools also has some extensions internally, which are really great. We created a custom exporter for our needs, which just creates the ordinary monolithic jar, and in addition to that, we just also provide some configurations, logging setups, and directory structure. In addition to that, we created a Docker build for all this stuff. That means we have a new Gradle task that afterwards can create a Docker image. Yeah, and we have a good runtime configuration. We can, for instance, create a runtime configuration for our backend, and just beside that, we create the runtime configuration for our edge devices. This is very nice, and if we make a release, we have 2 artifacts and 2 results. Then we use Jenkins for our continuous integration, and we have several build steps, build jobs, snapshots, release builds. The snapshots, are directly built. Usually we also make a Docker build, Docker image build, and we have the automatic artifact upload. We running Jenkins within the Docker environment, so in our case, we have a configuration that runs Docker out of Docker, and we have the artifact repository. This is Nexus, and we use it for our Maven artifacts that we create from BND, and as well Docker, a Docker registry, and now we also have an NPM registry that we can use in just one system. Yeah, and then we just need Docker and Docker Compose for getting everything running. And nowadays we do it by hand, especially if we do some development tests. then we just call a docker compose command that fetches the latest image and restarts everything. That's it in the end. So the conclusion of all that, I have to say we are a very small company, and we don't have that much personal performance. So everything in our company has to be very, very efficient. So, and exactly with the combination of OSGi, EMF as well, and the tooling and all the specification that OSGi provides, including all these nice implementations, we get very, very powerful setup to get microservice applications up and running. If you combine that with a nice build process and the correct tooling, for instance, I think BND tools and the Nexus Jenkins integration is very easy, then you get a system very quick. So, and you can take care for your business cases, and you don't have to, yeah, your architecture is well structured. I think it's very easy. If I see what is capable with our system in the end, just by what we have now, it's not that much implementation, it's just more combination, more architecture. This is what makes OSGi so special. Then in the end, we just have a few specifications. We have the JaxRS Whiteboard, we have the configurator and config admin, we have our RSA implementation, which is based on the Apache ARIAS project, and we have DS. That's it. Yeah, push streams and promises. Yeah, this as well, but wouldn't be necessary to use that. So, but it's just a few specifications to read and to use, and the architecture comes just due to composition of these specs, especially all the capabilities that the declarative services have, the configuration, the prototype, the scoping. This is these are the best features. And in the end, we have seen that with our edge devices. Our edge devices using the same bundles, the same APIs, the same implementations only. We have only one different configuration bundle with one meta configurator component in it. That's it. And in addition to that, we need a runtime configuration for that to create an artifact. And with that, I can combine my services at will. If you need a special desktop application that is just capable to handle my remote devices, no problem. Easy to do. I think I would need a new runtime configuration and, yeah, obviously a desktop client. And in addition to that, there is effective tooling for the development of OSGi components. So, and in addition to that, for the whole release and integration process. So we have nowadays all tools to create powerful microservices using OSGi and EMF. So I would say I'm just in time, I think. What? So any questions, comments? Yep.
I enjoyed your presentation. Very interesting. You have a lot of attention for the development work involved and then building of the application. But let's say all the hypes around microservices, etc., also look at operating the system and monitoring the system. I'm trying to figure out what all the initiatives that Eclipse publishes bring to the table, and you have the Jakarta thing and the microprofile thing and OSGi, of course. And what I would like to understand is how, for instance, microprofile standards could relate to work like you are doing, where you come to OSGi community and say, okay, we bring this out into the table. Is there kind of idea you have also on all the canvas micro profiles like to push and how OSGi could relate with them?
So I have to say I'm not only an OSGi developer, I also was involved in JE projects before the time of Jakarta EE, and I worked a lot with applications using JBoss Whitefly, for instance. And at the same time, we also had OSGi projects. And I don't want to say that I talk about JE. So microprofile is just making the whole JE stack a little bit smaller. Just create some certain setups for specifications you really need. So if you have a fully blown JE stack, then you're completely lost if you want to do such a simple application. And during my development time with JE, I experienced several problems I really didn't like if you worked with OSGi. For instance, having something like our service registry. This is something I really, really missed. And I have to say, I wanted to have a modular system. This was one of the main goals of this project, of this customer, and they said, we want JE, it wasn't my decision. And to get real modularity in JE is not that easy. Yes, sure, you can combine several ear files and you can have inter-ear communication, but is it easy? No, this is not the way to do it. And I believe, from my point of view, this is just my point of view, this is one reason why everybody said, okay, it's easier to put a REST front end in front of my application, in front of my beans. And then we talk about REST. I have seen that for years because before the whole Spring stuff came up, and I think there were a reason for that. And yeah, this is one point. I also miss to have multiple implementations for the same interface. They tried to resolve the problem with CDI, and you can get that in some way, but it's also not that easy than in OSGi. And I just have to say, I am used to this modularity, this programming style, and I will never switch back. I think I have seen what I would miss if I switch back to JE. So it's another framework. They have their own use cases, and this is, for me, it's just an alternative technology like also Spring. So, and but yeah, this is my style of programming. So I'm faster bringing applications on the road using OSGi than in JE. But I believe this could also be my problem and my colleagues' problems as well. Yeah.
Maybe I can add something to it. That
yeah.
I'm involved in enterprise OSGi, so I'd just like to add one thing. One of the things that we've been doing in the enterprise expert group is basically, before Jakarta EE started, even or microprofile started, is to be able to, if you like the OSGi way of developing, but you want to use Java EE technologies like servlets or JaxRS or any JNDI or CDI, then there are specifications in OSGi with implementations in open source that allow you to use these in a modular environment. So you can still use your servlets or you can still use your CDI beans, but at the same time take advantage of the OSGi modularity in the OSGi ecosystem. So that's the only thing I wanted to add.
Yeah, this is absolutely true.
This is also something I really like in OSGi. We started with the OSGi Alliance when the JaxRS Whiteboard came up, and we also created, thank you, an implementation for that, which is not fully compliant, but we have an own JaxRS Whiteboard implementation that works very well. And as we started with the specifications, I thought, isn't that too much? Isn't that too complicated? And when we started implementing everything, then we thought, oh, no, this is correct. Oh, it isn't that hard. And what you then get in the end is a very powerful system. 2 years ago, we had a talk about it. And you can start REST resources during runtime just by adding a new bundle. And then you have a new endpoint. You can remove them. Together with the EMF, we are capable to have multiple versions of models and multiple versions of REST interfaces at the same time. This is a benefit. I don't need a second ERR for that. I can have that in the same environment. So, I think.
Thank you, Mark. I think we're out of time. If there's any urgent questions, I think with that, let's thank you very much.